Welcome back. In this session, we will see the environmental and economic benefits of a circular economy. At the end of this session, you should know the environmental benefits of a circular economy and know the economic benefits of a circular economy. Reaching a circular economy, as shown previously, shall free our society from the so far used approach of take, make, dispose, the linear economy concept, to a sustainable and regenerative way of living. So far, our growth has been directly connected to the rate of raw materials and resource extraction. The more we extracted, the more society grew, or the more society grew, the more we extracted. The problem is that our currently used resources are finite, thus we cannot sustainably grow using this approach. Let's focus on this. Due to the global growth in the 20th century, which showed a quadrupling of Earth's population and 20-fold increase in global economic output, the demand for raw materials and resources increased from 600 to 2,000%, depending on the resource. Introducing a circular approach can achieve a decoupling of raw materials usage and growth. Our future growth is powered by the circular economy, not by more resource extraction, and with only minor addition of raw materials. The Ellen MacArthur Foundation labels this a growth within, and bases it on three core fields: preserve and enhance natural capital, optimize yields from resources, and improve system efficiency. Thus, achieving a circular economy leads to a conservation of raw materials and reduction of their use. Currently, the highest contributor to global GHG emissions are the energy systems, with 17.2%. Followed by the so-called AFOLU sector, which stands for agriculture, forestry, and other land use, with 11.9%. Industry with 10.2%, energy needed for transportation 6.7%, and energy for buildings with 3%. We can group the energy categories to one category called energy, and the other two AFOLU and industries, which are producing goods and products, to one category called products. If we do that, we can see that the energy section contributes to 55% and the products section around 45% of global GHG emissions. It is evident that we need to shift our energy production from finite resources to renewable resources, which will reduce the 55% contribution significantly. A lot of effort is already done in this area by implementing new power plants, based on solar, wind or geothermal, and the efforts will continue to grow. We would like to focus now on the other 45% of GHG emissions, the products section, and what a shift to a circular economy can achieve here. The Ellen MacArthur Foundation postulates three principles for reaching a circular economy: design out waste and pollution, keep products and materials in use, and regenerate natural systems. Let's apply them in the context of GHG emissions on the example of food systems. Principle 1. Design out waste and pollution, with the aim to reduce GHG emissions along the complete food value chain. Here we can focus on reducing food waste as much as possible with preventions, such as matching supply with demand to avoid wastage, discounting soon-to-be expired products, and using products which are beyond their shelf life in in-store restaurants. Other possibilities to avoid food waste going to landfill can be redistribution initiatives or ensuring that surplus edible food is used for human consumption. This can be achieved with using digital technology and supporting policy initiatives. Upscaling such initiatives globally could achieve a 50% reduction in food waste by 2030, and thus lead to GHG emissions reduction by around 1.4 billion tons of CO2 emissions per year. Principle 2. Keep products and materials in use. Cities are the biggest consumer of products and producers of waste worldwide. Cities produce about 600 million of organic waste yearly, while only 2% of it is looped back for productive use. The majority, as we already have seen, is disposed at disposal sites such as landfills. To reach a circular economy, we can introduce on large scale recovery processes such as composting. The nutrient-rich compost can be fed back into agriculture to regenerate the soil. GHG emissions are reduced by avoiding uncontrolled methane production on landfills. The Ellen MacArthur Foundation has shown that with a high recovery potential for organic material in large cities, like San Francisco, more than 70% can be recovered while reducing GHG emissions by 0.3 gigatons of CO2 emissions annually. Principle 3. Regenerate natural systems. A circular economy aims to return valuable nutrients back to the soil for regeneration. This approach also gives the opportunity to use the soil as carbon sink, and thus, to sequester CO2 from the atmosphere. One way to regenerate soil, for example, is to use a technique called regenerative cropland. This technique includes various approaches, such as no-tilling, use of cover crops, intercropping, and the use of organic fertilizer such as compost. The goal is to regenerate the soil, and to achieve a healthy soil, which in return sequesters carbon and reduces largely the need for any artificial fertilizer for farming. If 80% of the total cropland worldwide that is suitable for regenerative agriculture, and not yet farmed in this way, is converted to a regenerative approach, GHG emissions could be reduced by 2.5 billion tons of CO2 emissions annually. As we can see, adopting a circular economy approach can lead to significant reduction in GHG emissions, as we have shown it on the example of food systems, about 49% by 2050. Let's expand the scope beyond food systems, and also look into other sectors within the products category. If we include 4 key industrial materials, cement, steel, plastic, and aluminium, studies have shown that applying the 3 circular economy principles on these sectors can achieve an emission reduction of 40% by 2050. Together with potential GHG emissions savings of 49% in food systems, applying a circular economy approach could result in a 45% reduction in emissions by 2050 for the products category. Let's move on to the last potential environmental benefit of a circular economy, the protection of our ecosystems. Remember the 3 principles of a circular economy that the Ellen MacArthur Foundation created. If we take principle 1 and 3 and connect it now to the topic of ecosystem protection, it might become obvious right away, don't you think? Designing out waste and pollution, and regenerate natural systems. Let's have a look at the current linear economy with the take, make, dispose mantra. The last point is disposal, but if we manage to transition fully to a circular economy, we might achieve the ideal goal of zero waste. There would be hardly any waste, thus no disposal. What does it mean in terms of ecosystem protection? Well, we would hopefully not see these pictures anymore, polluted beaches and oceans. Microplastics would become a thing of the past. The Ellen MacArthur Foundation demonstrates the circular economy of plastics. Current estimates in today's linear plastic packaging economy show that at least 32% leakages of waste are going into the environment, causing pollution of our ecosystems. In a circular economy approach, we would ensure that all plastics we need are reusable, recyclable, or compostable. We would try to achieve the ideal of a zero waste by designing out waste and pollution. Remember Principle 3, regenerate natural systems. Introducing, for example, precision farming with new technologies and regenerative agriculture principles with organic fertilizer will not only make the agriculture of the future more efficient, but also regenerate the soil and protect the ecosystems. The amount of artificial fertilizer needed for farming can be drastically lowered or even made obsolete. Together with precision farming, runoff of nutrients from farmed fields into the environment will be close to zero. Why is this important? Eutrophication, mostly caused by the agricultural runoff from over-fertilization, is a severe pollution of our ecosystems. Too many nutrients released into the environment causes algal and aquatic plant blooms and can threaten our fresh water supplies. Regenerative farming with precision technologies can reduce this negative impact, as over-fertilization will be avoided. Additionally, shifting our agricultural practices will also regenerate our soils. We can achieve healthier soils that will grant a sufficient and sustainable agricultural output for generations to come. Now we have seen some of the environmental benefits that a shift towards a circular economy can bring. But it is also important to have a look at economic consequences of changing our current linear model to a circular one. Will it cost more, or is there an economic advantage? A study on behalf of the European Commission conducted by the GWS Group found out that each % reduction in resource or raw materials use would generate 12 to 23 billion euros and create between 100,000 to 200,000 new jobs. Thus, we can see that shifting to a circular economy which reduces our intake of finite resources can also have positive effects in terms of costs and create employment. The Ellen MacArthur Foundation has analyzed the impact of a transition to a circular economy in Europe for 3 essential segments: food, mobility, and the built environment. Results show that a transition can increase the household disposable income by 18% in 2030 and up to 44% in 2050. But also increase the European GDP by 11% in 2030 and up to 27% in 2050. In both cases, the increase, if we were to continue with business as usual, would not achieve the same growth. Therefore, we can see again that it is truly worth economically to create a circular economy. Other positive impacts on direct user cash-out costs, societal costs, and CO2 emissions could be observed. Previously, we have seen that a decrease in resource use can have positive impacts on costs and employment. And the study shows that with a transition, we can reduce our consumption of primary materials even further, compared to the current development. We would reduce costs and create more jobs at the same time. We can clearly see that it is another win-win situation when we move our economic activities into a circular mode. It's a win for the environment, but also a win for society by reducing costs, increasing economic gains, and creating jobs. We have reached the end of the session. Let's summarize our learnings. We have learned about environmental benefits of transitioning to a circular economy, such as reducing our intake of raw materials and separate growth from resource use to achieve a growth within, reduction of GHG emissions, and protection of our ecosystems. Then, we looked into economic benefits on the example of Europe. We saw that a reduction in raw material use can positively impact costs and employment. Further improvement compared to the current development in various fields, such as disposable household income, GDP growth amongst others, is possible with transitioning to a circular economy. Thanks for listening. Feel free to go over the 3 principles of circular economy and see how they could be applied to other sectors reading the additional resources of the course, available under this video. See you soon.